to improving performance by running MySQL multiple times. For those people who don't know me already, where have you been all week? My name is MC Brown. I'm a technical writer for MySQL, but people have described me as having additional agendas, which pretty much sums me up. So I get involved in lots of other stuff as well. What I'm going to talk to you about today is different ways of running MySQL multiple times and how you can use it to tune and tweak, and in some cases really improve performance. And I wanted to start with something really significant. So I started with this slide. The people who read Planet MySQL, Jenny Chen, who works for Sun and does a load of investigations, she just published a load of statistics just recently, and she's taken one of Sun's big CMT boxes. These are the boxes that run 128 threads at the same time. And she went in and created a MySQL database, used it with DB2, and if she did it and ran it one time with 32 threads, then she got about 22,000 transactions per second. If she repeated the test and this time actually created 8 instances of MySQL, each with 8 threads each, but still with a 32 thread on a DBT2 benchmark, we basically got 3 times the performance. And the reason that we got 3 times performance with this is because the disk contention on the individual machine was such that we just weren't able to read enough information from the disk at the same time for a single instance of MySQL to be able to handle everything. You've got this big powerful machine, it's got capability for 128 threads. If you can't load the data quick enough, it doesn't matter how many threads you've got. But we can take advantage of that, run MySQL multiple times and get something completely different. And in this case, this is amazing. What she did is she took each of the individual disks, she gave each instance of MySQL its own disk, so there was none of the disk contention you were trying to run a big service. You've got one dedicated disk for each one, and you can just see the performance difference. So this really indicates that actually hardware is the driver. It is very difficult nowadays not to go in and buy a machine from Best Buy or somewhere similar and find out that you've got 4 cores or 8 cores, for a relatively inexpensive price. Most of these machines have lots of RAM. I remember many years ago when RAM was really expensive, and now it's very easy to pick up 2 gig, 4 gig, 8 gig of RAM for such a small amount of money. It's not true. Fast hard disks, fast interfaces, SATA is fantastic, SAS is even better. The ability to get information in and out of the server is really quick. And of course it's very easy nowadays, PCIe, the ability to have multiple network interfaces and take advantage of that is equally a very good reason for being able to get these very fast machines for relatively little cost. And even if you go up to the complexity of one of Sun's CMT boxes, the amount of power you get in a box for the cost, actually it's pretty good price comparison. So when I talk to people about running MySQL multiple times, most people turn around and say, you are mad. Why would you run MySQL multiple times? Just as a poll, anybody here ever tried running MySQL multiple times on the same box? Anybody see a performance improvement when they did that? You are my best attendee. You've been to so many of my presentations and you're always just so fantastic.
Why you speak my language, mate?
Most people would look at it and say, what a waste of resources. I've got this big fast machine. Why would I sit there and just run MySQL multiple times? Surely I should be able to get better performance by, taking advantage of the fast disk, taking advantage of the extra RAM. And sometimes it just simply doesn't work that way. It's as simple as that. And lots of people also say it's a waste of opportunity. This big machine, we should be able to get the maximum performance, we should be able to do what we want with it. Again, it doesn't work. And the other thing that people say is they look at it and they say, but if you run MySQL multiple times on a single machine, isn't this a single point of failure? Well, no, it's not. It's only a single point of failure if you are stupid enough to consider it a single point of failure. I'm not suggesting you do an 8K on a single machine. That's ridiculous, right? High availability on a single machine is, you really need to go back to the basics. And the other thing is people say, doesn't it introduce a load of management complexity? And it doesn't introduce any management complexity. If you've got 10 machines all running MySQL, is that any different from one machine running MySQL 10 times? Does somebody want to disagree with me on that particular item? Okay, that's good. So, more often than not, just occasionally, if I'm able to convince people, they say I'm a genius. Some people look at this and think, you know what, we could do some really, really interesting things with it. And you can. More flexibility. It is very, very, very difficult if you're looking at MySQL multiple times, you've got different workloads on different machines. You know, the ability to condense that together and to make better use of your hardware. You know, you've just gone out, you've bought a $2,000 box, but you don't want to buy 10 $2,000 boxes to run all of your different MySQL services. You know, if one of your MySQL services is not even able to use 1% of that $2,000 box, why are you running it on a $2,000 box? Again, does anybody see any problem with that? Come on, work with me, people. I know it's the end of the conference, but... Okay, so the thing with running MySQL multiple times is we get the ability to more finely tune our resources. We can go in and specify how fast we want different components to be, how much RAM we want to do. We've got different systems, we've got different MySQL running different applications and being used in different ways. We can control those resources very, very finely by running it on the same machine and running multiple instances. And we also gain other elements from that. We've got security and isolation. Lots of people want to be able to run MySQL multiple times for their customers or for their different departments. That doesn't stop you from having a secure installation of all of these different components. You can still provide a secure installation. You can still provide the separation that ensures that people are not going to be able to get information from one instance that they can't get from another. You also get the ability to control your performance. Some of the places I've been into, you've got people who are running MySQL and they think about running it multiple times, or they think about running MySQL on a box which is doing other things, but you don't want anybody to come in and run some query that brings the whole MySQL server and the rest of the box to its knees if the machine is also doing other things. But if you can control the resources and control the performance, you can go ahead and say, with all sorts of different solutions, which I'm going to demonstrate in a minute, you can go in and say, you know what, I only want this machine to have one CPU. I've got 4 CPU cores available, I give 1 CPU core to this, and it doesn't matter if someone runs a stupid query, they're only ever going to get 1 CPU core out of my machine. Now obviously, another thing, very, very simple, lower cost. For these people that go out there and buy an individual MySQL machine for each MySQL instance, if you're not getting maximum performance out of every single one, or 90% performance out of every single one, right, you're wasting money, and you're wasting a lot of money. You know, a decent top-end MySQL box is probably capable of handling more than 1 MySQL instance. If you have 10 MySQL instances running different applications and running different solutions, that's a lot of money that you might be wasting, that you might be able to condense down into 3 or 4. And it's also ultimately about more than being able to handle just a single database. We're talking about handling different databases, different workloads, targeting your database and targeting the performance that you have in your individual boxes into exactly where it's needed. So although I gave you that headline figure about, increasing our performance by 3 times by running MySQL multiple times in DBT2, what about those environments where you have different departments, and different departments need different performance and different resources, and you can take the advantage of running MySQL multiple times to control those individual items and put it onto a single box. So what does this mean in practice? Yes, sorry.
If we have multiple instance installation of MySQL, can we do verification for each instance?
Yep. I will show you some examples of some clever, freaky things that we can do towards the end of this presentation. So, a key thing with running MySQL multiple times is usually if you're looking at running MySQL multiple times, you're looking at it because you think you've got some kind of bottleneck somewhere. And the traditional model for solving bottlenecks sometimes is to think about scaling out. And in fact, I did a tutorial about that on Monday. Scaling up and scaling out and increasing your performance. But actually sometimes the bottleneck is a bottleneck that isn't fixed by scaling out. It's a bottleneck that you can fix in some different way. Jenny Chen's example, that headline slide, is a very good example. She got disk contention even though she was using RAID with 1 single MySQL instance. She gave 8 instances their own disks. Suddenly the disk bottleneck was gone. She could read information off of the disk individually because she wasn't having to worrying about crossing all of the disks and picking up the information. So what it does is it turns this traditional model that we might consider, and I've just taken the example that we might have a 4-core machine and it's got a disk device of some kind. I'll go into more detail on these individual elements later. So you've got this kind of a system, so you've got one MySQL, you've got 4 CPUs, you've got one disk interface, one disk device of some kind, you've got some kind of contention, and you just turn it into this. Multiple MySQLs, multiple CPUs, multiple disks. Is everybody following me here? I'm seeing a few nods, but it's before lunch, and you know, we're all thinking, oh, last day of the conference, lunch, I can go down. Yes?
Clarify, you're talking about segmenting multiple instances by actually doing virtual operating systems to run one instance of MySQL of those, or actually running multiple listeners?
I will show, we haven't got to that part yet. In fact, that's actually the next slide. So the point here is that you get contention in different places. You need to understand, I mean, something I kept saying in my tutorial on Monday, right, test your applications and find out where your contention is. If you've got CPU contention, then you can consider about upgrading to another box, but probably, you know, that's not a good example of being able to run multiple instances is good, because obviously if you've got the CPU, it's very, very difficult to upgrade your CPU. Upgrading your RAM, changing your disk structure, changing the way your MySQL instances use those underlying devices. These are all things that we can tweak and play with. CPU cores is a bit different. It's very, very difficult to actually change the CPU cores on a machine. We can change the machine, but if you're going to change the machine, you might want to look at some other solution. So what are the techniques for running MySQL multiple times? Hopefully I have caught as much as I can in terms of the different systems here. I realise there are probably going to be some exceptions, and I'm going to go through some details on the individual elements here. But you know, the simplest way is just run multiple instances. Just run MySQL D safe, specify a different port, and run it multiple times. It is the simplest way of doing it. There are some limitations to this particular model, which we'll go into in more detail in a second, but it is the simplest way of getting it. You can get some simple performance benefits. Full virtualization. How many people here use virtualization of some kind? Are you using virtualization in production? Yeah. VMware, yeah. Anybody using VirtualBox? Oh, one using VirtualBox. How long have you been using it?
A year.
Yeah. Good. How many people, just out of interest, using Parallels? Anybody using Parallels? No, not even Parallels on Linux? Zen, I mean, is a good one. Lots of people are using Zen. And just as a complete aside, what kind of an operating system spread have we got here? I mean, I'm sure if I probably said Linux, I'm going to get most of the hands up in the room. Is that right? Well, actually, I only got 5. So I'll ask it again. How many people are using Linux? Sorry? No, just generally. How many people are using Linux? Okay. How many people are using Solaris? And how many people are using Mac OS X? I'm guessing there's probably a few exceptions here which are BSD. No BSDers? Okay, Windows. I'm always surprised by the number of Windows. You know, we have loads of people apparently using MySQL on Windows. We just don't seem to get them into the conference thing. So, full virtualization is great, you know, including the hardware-assisted things, the Zen, the ability to go in and use, you know, virtualization within the hardware, virtualization within the CPU. There are some advantages. I'll look at those in a second. Para-virtualization. So, is everybody familiar with logical domains? Nobody familiar with logical domains? Okay, on the CMT boxes, this is the chip multi-threading boxes from Sun, you can do this thing called logical domains. And logical domains enable you to sort of create within almost within the BIOS, that's a really bad way of describing it, but almost within the BIOS, you can create an individual section of the system. And that means that you can go in and divide it up, and you can say, oh, I want 32 CPUs to be given to this, or 32 threads to be given to this. And it's not quite full virtualization, but it's not actually quite the other end of the scale, which is the Solaris containers. Solaris containers, Linux vServer, BSD jails, these things are APIs to the operating system that kind of simulate a separate operating system environment. Solaris containers is what Jenny Chen used. I'll go into a bit more detail about it and how it works. But all of these techniques, we can go in and have a look at these different elements and work out kind of the performance and where we're going to get the advantages. So multiple instance techniques, I've said it already, run MySQL D multiple times. I mean, it really is that simple. There's nothing complicated about it. The most complicated thing you have to do, obviously, make sure you specify different data directories, different base directories if you need to. The one that people often forget is specify a different TCP/IP port to communicate on and a different socket. If you're using Unix sockets for your communication or Windows. Sorry? Yes. I mean, you can just make sure to do it. I've seen people do it and then forgetting, and then of course, oh, hang on, it's already. What do you mean it's already in use? Well, of course it's already in use. You're running it multiple times. So all of these things. I mean, it's very, very easy. There are some problems with running MySQL multiple times just by running MySQLD, and that is we have a fairly limited amount of control. The only way we can control the system and control the way that we can use it is by using the MySQL configuration file. Okay, we actually don't have the ability to go in and specify in it. I can't go into MySQL and say don't use anything more than 2 CPU cores. I can specify the threads, I can specify the maximum number of connections, but I can't go in and say, you know, don't go nuts on the CPU if you happen to have a really complicated query. I can't get it to do that. I can get it to use a specific disk device. I can get it to use a certain amount of RAM. Again, there are some dangers with going in and doing that certain amount of RAM because, to me, it's not very protected. But, you know, MySQL, multiple instances, very easy, very convenient. Mostly, it uses resources sensibly. Are there any problems with it? The problems mostly I've already described. There are some other issues. The security is not so good because at the end of the day, you're relying on file security. You're not relying on any kind of actual, almost physical separation. It sounds silly within a single box, but you'll see what I mean. So, the next type is to go in and have a look at true virtualization. Now, true virtualization is probably what most people in the room are familiar with in terms of virtualization techniques. So this is VMware. This is Parallels. This is going in, creating a brand new virtualized instance, and within that, creating a new operating system. And the great thing about true virtualization is that we have the maximum level of control. Without exception, with these systems, we get the maximum level of control. We can go into VMware, we can go in and specify how many CPUs we want to give over to a particular instance, how much RAM we want to give over to a particular instance. We've got control over the type of disk that we want to use in each case. So we've got to have a huge amount of control, and ultimately we also have control over the operating system we run. I mean, how many people here use virtualization as a way to run on multiple operating systems? So you're, right, how many people are using it in production? Sorry, just to add that right. So what are you doing? You're using Linux and then running?
It's ESX.
Right.
It's network ESX, and then there is some space environment. And Windows
Yeah. So VMware ESX, for those people that don't know, is one that a higher level than just kind of running VMware Workstation. It sits there as almost as an operating system in itself, and then allows you to run the server. So, I mean, the great thing about this as well, and the one thing I particularly like about VMware and Parallels in particular, they all allow you to go in and specify things like creating new network interfaces, and I can bind network interfaces of an individual item onto a particular network interface port. So when it comes to virtualization, I'm almost creating a completely separate individual machine, and I can dedicate my resources to it. I can dedicate a hard disk, I can dedicate a hard disk subsystem, I can dedicate a network interface, I can dedicate those CPU cores, and I've got a lot of control. Problem are you're running a full operating system and you're doing effectively emulation. I mean, this means that the performance is going to suffer just slightly, because you're effectively running multiple copies of the operating system, and so you've got these additional layers that you're going to have to work with.
There's a whole slew of problems with VMware that we will have to spend a lot of time on actually fixing some of the things that come with CentOS, different parameters in between, different limitations that you have to be aware of before you just kind of follow things correctly. And then if that keeps over.
You need to be really, really careful. It's very easy within VMware, for example, to start doing silly things like specifying too much RAM. You know, Parallels actually, if you use Parallels, it's even worse than that, because Parallels will enable you to use swap, which kind of completely defeats the object of being able to run MySQL multiple times. If you're using swap, forget it.
So VMware on this, if that on an E-core machine, you only really have 7 cores available to you. As the actual hypervisor and actual process control flow, the whole thing takes
Zen's the same, actually. You know, .0, .mu, etc. You get exactly the same issue. Yes.
So my name's Jennifer. I'm actually from Sun as well. Jenny Chen's on my team.
Right.
And we've been working with VMware, so there is a paper out there for MySQL and VMware.
Yeah.
You know, head-to-head comparison. It's minimal difference. And there will be further work. So I just want to say that they're looking for best practices tuning. That sort of, we're talking about that. If you see some, the thing we've done right now is very
I've seen some stuff on that one.
very generic, but it's going to get better. So you'll see more work there.
So, yes.
Yeah, we also use VMware, but on the ESX3
Yeah.
is excellent because it's on the first layer,
Yeah.
no OS dependent. So we have that on our 8-core machine. Then we have about 4 or 5 Windows servers
Yeah.
and another 5 OS. They run so well. So yeah, so far no problems.
Yeah. I mean, VMware is very popular, and you know, EC2 uses Zen, which is just another virtualization solution. I really like some aspects of Zen, but I don't like all of them. But anyway, so true virtualization, we have some issues. We have some positives because we get so much control. If you want to have a look, I don't want to specify almost that this is necessarily a panacea, but if you go for these quasi-virtualization techniques, logical domains, Solaris containers, BSD jails is kind of a separate thing, which I'll explain in a minute. But these things are a system where you're not actually doing a full emulation of an operating system. It's an API into the underlying operating system. So rather than having to emulate an operating system, it passes an API through the call to the underlying system. So with Solaris containers, you can go in and create X number of Solaris containers and devote, you know, a certain amount of CPU and a certain amount of RAM to these individual containers. And you can control which disks they use and whether they share information from the host or whatever. Solaris containers is amazing. Logical domains is even more so. I mean, I'm sure you are. I mean, logical domains is so fantastic. You can sit there on a running system. You've got 16 CPU, 16 threads that you're running, and you suddenly go, hey, you know what, I've got a huge amount of load, I'm going to give it 48 instead. You can go in and give it 48 without rebooting the system. I mean, just, you know, I need the extra power, give it to me. And that's something that you actually can't do on, you know, running MySQL on a single system, let alone running it in any kind of, you know, any kind of the full true virtualization systems, where of course you have to reboot the system to tell it that you changed the configuration.
Some of the things you can do is you can change the security reasons.
Yeah.
That's such a big word on.
Yeah.
If you want to change that, what
So, of course, chroot. How many people are familiar with chroot? Okay, chroot is the poor man's Solaris containers. It gives you absolutely no control whatsoever, but it does at least create a separate security environment. So if your purpose is of running MySQL multiple times is to take advantage of security, chroot is a very good system. BSD jails is kind of the next level up. BSD jails, you can create separate secure environments to run your different MySQL instances in, but you have no control over CPU, you have no control over RAM, you've just created a separate secure environment. Solaris containers, zones, logical domains, and Linux vServer. Anybody use Linux vServer? It's kind of a bit of a subversive project. Linux vServer is basically Solaris containers for Linux. It's worth having a look at, just because it does some of the same stuff, but it doesn't seem to be a popular. Yeah.
It's also part of all these components.
Yeah. Yeah. So anyway, all of these things, I mean, all of these quasi-virtualization techniques, you tend to get the best combination of performance and control, because we can control different elements, we can control CPU, we can control RAM, you get the better performance because you're not emulating a full system. There are, the limits in terms of how we can control different elements of the system are obviously much better. There are limitations because we can't run a different operating system. I'll just add a rider to that. With Solaris containers and logical domains, you can run Linux, you can run, what it's called, branded zones, BrandZ. You can run certain versions of Linux within containers on Solaris, which again is another cool feature. It's not quite quite as good, but it's pretty good. Problems, largely very, very few. So, with all of these systems, and I'm going to give you common tips across all of these systems, because I can tell you right now that you will hit the exact same problems running different virtualized environments. You're going to go in and find the same issues. And the issues are always related to some kind of resource. Right, so when it comes down to CPU, don't overdo it on the CPU. We had a very good example here, ESX, VMware ESX. You run it on an 8-core server, you've only got 7 cores to give to your virtual machines. Don't try running more than 7 virtual machines with 1 core each. Okay?
Unless there is a little CPU value.
Yeah.
That's the caveat that if you are running a machine with 7 available CPU amenity, so
Yeah.
do that for all the apps that you run production on the environment.
Yeah. I mean, the problem there is that doesn't stop you as much as some other solutions have having that runaway machine that starts consuming CPU power, which can be a real issue. And if you're trying to do it as a level of control, you want to control the CPU power in such a way. I mean, CPU affinity is a great way of saying, this virtual machine uses this CPU core. You've got a lot more control that way. RAM, swap is a no-no. How many people here think swap is a no-no? That should be everybody, right? Okay. If you're ever getting into the point where you're using swap on any system, running MySQL multiple times or otherwise, right, swap is a bad idea. I've had philosophical discussions with this with people before, right? If you're going out to swap, you've set your RAM too high, you're going out to swap, you're doing the wrong thing. Okay, because the moment you go out to swap, you go out to disk. Any illusions you had about the performance of your system have just gone away. And unfortunately, some virtualization environments actually will let you specify ridiculous amounts of RAM, even if you don't have it. Parallels is a very good example. It's the only reason I don't really like Parallels. Parallels will let you go ahead and use, if you've got a 2 gig machine, for example, it will allow you to use 1.5 gig of your RAM to run a virtual machine. But what it will actually do is it will let you use 1.5 gig of RAM for each virtual machine you want to run. Right? It doesn't stop you from running multiple virtual machines if you want to use up lots and lots of extra RAM. So you can run 3 virtual machines and use 3.5 gig of RAM, and you've only got 2 gig. You're going to hit performance issues. Yes? I haven't heard of anybody using SSD for swap. I know that there are people working with it for SSD for swap. I think the consideration with SSD for swap is a combination of potential performance issues and a longevity issue, because SSD is, I know people are hitting longevity issues with SSD, or they're hitting performance issues. I mean, I'm sure some of us have seen the recent things. Intel found that some of their early SSD disks, you start using them for more than 6 months and you get half the performance. So I think that's something that will come on stream and will improve over time. And that will make a big difference. I mean, we're already seeing a big difference with ZFS nodes. If you were in Alan Packer's ZFS presentation yesterday, you can get huge performance improvements by using SSD for the ZFS cache. Yes?
DRAM's cheaper than SSD if you're running out of RAM.
Yeah.
More DRAM.
Yeah. And RAM itself is cheaper. I mean, I said it right at the start. I can remember, sadly, I'm going to slightly show my age. I can remember 17 years ago, we spent £10,000 on a machine, and £8,000 was for 136 meg of RAM. Right? Okay. Now I can't actually buy that small amount of RAM now, but for the same amount of money, I could buy so much RAM. I could probably buy everybody 4 gigs of RAM in this room right now for that amount of money. I mean, that's just how cheap it's got. If you've got a machine, it's really, really easy to get a machine that supports 8 or 16 gig now. You should use it, particularly if you want it for virtualization. And 16 gig of RAM is a lot. I mean, there are people who run servers with only 4 gig of RAM. You've got 16 gig of RAM, you could run full servers. You've still got all the performance, you've still got all of the control. Disk. I have a contentious feeling towards disk contention. And I use that very, very, very specifically. Disk contention is a real issue if you start running MySQL multiple times. right? It doesn't matter what solution you're using. If you're running MySQL multiple times, disk contention is going to start to be an issue. And the reason it's going to be an issue is it doesn't matter if you're using RAID, it doesn't matter if you're using ZFS. If you've got lots and lots of things trying to access the same areas of the disk at the same time, your disk contention is going to go up. And it doesn't matter if you've got 2 spindles, 4 spindles, or 8 spindles. You know, the amount of time your disk is going to sit there scanning around over the disk to load individual bits of information is just crazy. So I'm not saying don't use RAID, but use RAID sensibly. If you're going to use RAID, and you want to be able to take advantage of, say, striping to get better performance, create an individual RAID device for each of your virtual machines. Or use physical disks for each of your machines. VMware will enable you to go in and say, use this SCSI drive as the original, or use this SATA drive as the original, rather than you creating a file on a file system that you load in. Files on file systems with virtual machines, really a bad idea. You know, dedicate a single disk to it if you can, use RAID, use striping if you want to, but dedicate it to an individual machine each time. And remember, longer term, as you look over these different things, the speed and performance of your system is going to be directly attributable to each of these individual elements. And I know that sounds like an obvious statement, but you might find that actually you start running it multiple times and you find that your disk contention has suddenly gone up, even though you've dedicated a couple of disks to it each time. You can't get around that. If you're using one RAID 5 volume or one ZFS volume, you can actually kill the machine by running MySQL multiple times, because it spends so much time trying to scan all over the place with these disks. It's just ridiculous. And I've seen it. I've got some nice Sun hardware at home. I get to play with this kind of stuff all the time. So, the other thing with disk interfaces, the other thing with disks is the interface itself. Okay, if you're going to use it, try and use the fastest interface you've got available, and try and consider that if you're going to use multiple disks, try and use an individual interface for each disk. So don't use any of the clever things that enables you to connect multiple drives up to one SATA or one SAS interface, because you're going to kill the performance, because you're trying to squeeze all of that performance down a single cable. Same when it comes to RAID. Don't use an external RAID device and then connect it via SATA. You've just killed your performance and any advantage you might have with that RAID system if it's all going to come over one SATA cable. And I'm specifying that because I've seen people do it. They think, I'm going to run the virtualization. They run virtualization and then they get the RAID box and they connect this SATA RAID system, and suddenly the performance dies. And you think, well, yeah, you can only fit so many disks worth of access down a 300 gig rather. A 3 gig per second SATA connection. And the other one, network. Lots of people forget networks. If you're going to use virtualization of any kind, use multiple network interfaces and dedicate a network interface if you can to each virtual machine that you're doing. If you're not doing that, try and set it up and do it sensibly. So try and split it up and make sure that you've got equal levels of load. If you've got something that has a relatively low number of client connections, put it with something that also has a relatively low number of client connections, so that you don't saturate your network interface. Because network will start to be your problem. Yes.
One of the things with VMware is that VMware will provide an E1000 driver.
Yeah.
But there's also, and that gets your own limitations of that driver. And there is a way to get a VMware driver exposed to the OS.
Yeah.
It'll be much faster. And that it's not any of the interfaces, but it is available there. So if you're using VMware, talk to your VMware router.
Yeah, use the drivers that come with virtualization.
Is it only VMware still?
Not sure about that. It is limited to technology. But they're basically saying that there's a much faster and much less volume driving compute. So it's counter many problems with this.
Okay. And the last comment just at the bottom here, use direct connections. I mean, if you can, use direct connections for anything. Don't rely on anything that's virtual, don't rely on anything that's shared. And when it comes to the virtual machines, the same thing applies. Use a dedicated connection for each one. So I started this out, one of the things I mentioned was high availability. Okay, if you're looking to use running MySQL multiple times, and you're worried about high availability, all you need to do is change the way you look at your high availability. Okay, the high availability does not change. You're not going to get high availability by running MySQL multiple times on the same box. I've already explained that. And again, I'll ask, does anybody disagree with me on that? Okay, all right. I'm just making sure. So, I mean, here's a typical environment. Okay, let's say we've got three different MySQL servers, we've got 3 boxes, and a typical way of doing high availability. Let's just assume for a second that we've got every single one is on high availability. You'd have one backup machine. So you've got 3 MySQL instances, you've got 3 servers. You actually need 6 so that you support your high availability installation. But if I'm running MySQL multiple times, how do I do it? Well, all you do is you change it so that the high availability is on the machine, not on the individual instance. Right? Okay, so stop trying to think about individual. You can run DRBD, you can run DRBD and have different devices. If you want to use DRBD, you can use Solaris Availability Suite. You can do all of the different solutions that you can. You can still do it with one box, but you just fail over to another. The reason there are 3 items on here is because what happens if you fail over and your failover box fails? Okay, or you want to do administration on your box, you still want to have a failover box available, right? So use 3, and that means that you can be doing updates on one, doing administration, whatever it is on one machine. The other one can sit there and be the hot spare in case of a failure, and then you can, change them in a nice round-robin fashion. What about scalability? It's basically the same as you would treat with HA. If you need to do a scalability solution, you need to scale out, you need to do replication. Do replication from the boxes. There's nothing stopping you doing replication multiple times from multiple instances. I mean, you don't have to think about replication coming from only one box. It's coming from one MySQL instance. If you're running 10 instances, you can run replication from each one. But, a rider to that, be very, very careful when you're doing that, because if you don't have enough network interfaces, the load on replicating 10 individual MySQL instances over 1 or 2 network interfaces, you might run into simple performance problems transferring the bin logs each time. How many people here use replication, just out of interest? Replication. How many people use replication as part of their HA? Okay, so I've done it here, match resources to Unix. Try and give this some serious consideration. So, I've talked a lot about all of the different solutions, the different ways in which we can do it. What are some of the clever things that we can do? One of my favourite is to deploy cluster in a box. How many people here use clusters? Are any cluster people? I don't recognise any of the cluster people I saw. Okay, cluster is a complicated system, but fundamentally, cluster you have different nodes that handle data, you have different nodes that handle the management, you have different nodes that provide the SQL interface into the information. And normally you would use multiple machines. And the whole purpose of using multiple machines is that actually you want it for HA or you want it for pure speed. But you know what? If you've got one of these big boxes that have got lots of CPUs, put a cluster in a single box. You get all of the advantage of having a nice expandable system. You can attach loads and loads of SQL nodes onto your cluster in a box and get some real performance advantages if you can sit there and allocate your resources effectively. And I know people that are doing this, and better still with a cluster in a box, you can start doing some really interesting things and start connecting a cluster in a box and another cluster in a box together and replicating between the individual elements. This means you've got one pizza box with a cluster in it, you've got another pizza box that can be connected to it. You can expand your cluster really, really easily and still benefit from the ability of running MySQL multiple times. You've got flexible combinations, you can do all sorts of different things with your replicas, with your data stores. You can split it out onto different disks. It's a really, really, really nice system. I put a cluster in a box on an X4150, which is one of Sun's Intel boxes. So it's got 8 cores, it's got 8 disks. You can get some real performance out of a single box just by sticking a cluster onto this single box and running multiple times with containers. I think there's Jenny Chen's done something. Jenny's done some work on a cluster in a box, hasn't she? She's got a blog post out there somewhere. I don't think I've got it with me, but. So another solution I like, and another solution that I have seen done, is actually to think about deploying a shard in a box. So are we all familiar with shards, the ability to split up your network, divide up your network? What you can do is you can just deploy a shard in a box, which sounds like a completely stupid thing to do because the whole purpose is of shard is to be able to increase your performance and scale out. But actually what you can do is you can create a master and slaves all within one box, and then change the configuration of the individual elements. So your master doesn't need to have a load of cache. You might want to give it index cache so that it can write information into the tables really, really quickly. But it doesn't need to have a lot of other cache, so you can give it a relatively little amount of memory and stick it onto a dedicated disk. Then you put your slaves, which are replicating from the master, and you can give them as much RAM and as much RAM cache as you want. So you get into this situation where you've got a single box that is both the master and multiple slaves, and that you can scale out. And you've taken advantage of the fact you can have 16 gig in a box, but you don't want to give 16 gig over to just the master. That's usually a complete waste of time, because you're just never going to use that amount of RAM if all you're doing is pure writes on the master. How many people think that's a cool idea? Some sort of slight nods. Yeah, here. It's one of those things, it takes a little while for you to actually think about it and realise, that actually you can do some freaky stuff. Remember, you've got complete control over all of these individual elements. But you want to control and give your master so that it's writing out to a really, really fast box, a really, really fast disk. It doesn't necessarily have to have a dedicated network interface, but you've got slaves that can have their own dedicated network interfaces. You can do some really interesting stuff. And when it comes to scaling it out, you've got this nice little shard in a box. You want to replicate it, duplicate the system. You've got another shard. You keep spreading it out like that. And the last one I want to show you, the multinational in a box. This is one of my favourite ones. I've been into places where they've got applications, and they've got some applications which are using loads of CPU cores and loads of resources, and they've got other applications that are using relatively little resources, but they've got an individual box for each one. And this is just a complete waste of time. Okay, we've got people running $500, $1,000 boxes for a MySQL database that gets less than 300 queries a day. I'm not going to say a second, less than 300 queries a day. So what I've done is I've gone in and I've had a look at it, and I've set up, in this case I use VMware, and I just organised it so that I could dedicate a certain amount of CPU, a certain amount of RAM, and the disk storage available, so that instead of having 4 boxes, they actually only had 1 box. Was there any difference in performance? None whatsoever. Okay, they got exactly the same performance statistics out of 1 box, out of which they got out of 4. But they weren't paying for the electricity, they weren't paying for the boxes. And this is probably the most obvious solution for running MySQL multiple times, because it really eliminates that need to have all of those boxes. And electricity, cooling, everything related to that is, most people's pain point at the moment. So, what I did, just to give you a quick rundown, I set RAM, I set connections. For the MySQL, that wasn't used very much. It had 1 connection. I think I actually set it to the minimum, which is 16 or something. For the other ones, I gave them loads of connections. It didn't matter if on the box that wasn't doing many connections, if I ran around a really, really stupid query that would have tied up the box, it didn't tie up the box. All it did is it tied up the CPU that I dedicated to that virtual machine. Nobody else was affected. Someone did a stupid query on that instance, it didn't affect the people who really needed the performance. So I haven't lost anything. I've gained so much. When it came to HA, all we did is duplicate the box. Duplicate the entire virtual environment, have replication between the two. In fact, we use DRVD, but the same fundamental system. Really, really, really great. Really, really, really simple. And at the end of the day, really, really, really cheap. I hate to bring it down to money, but actually that's a big driver in this environment. So, any questions that we haven't already covered? Anybody got anything they would like to ask? Yes.
So we use multiple replication slaves in order to scale out.
Yeah.
Because we're dealing with a large amount of traffic, large number of queries from our web app service.
Yeah.
So with the advent of SSD, we're actually using some of the new Fusion I/O cards which we use to use those.
Yeah.
Obviously, I/O bottleneck has gone.
Yeah.
Okay, which is the holy grail there.
Yeah.
So our next bottleneck is MySQL contention itself.
Yeah.
This is why we're exploring multiple instances for these particular replication services. We actually use multiple instances already for our backup service.
Yeah.
Because we have 6 databases. I have 1 backup server for these 6 databases. And it's fine. 6 instances, it's great. So my question to you is, now that with the advent of SSD, you can eliminate the I/O bottleneck. If you're using multiple instances, is that really going to give you a benefit in terms of ensuring that a single MySQL instance isn't going to max out on its number of connections?
Very, very, very difficult question to give a very, very quick answer to, because it will depend entirely on the type of the application. But you may well find that actually the amount of time that you're spending within MySQL itself on one instance, I mean, and this is partially what Jenny found with that headline slide. You know, what you'll find is that there are a lot of locks on the individual tables which you might be able to eliminate, and it doesn't matter whether the contention is at the disk or whether it's at the point where you're doing locks on the individual tables. Anything you can do to spread that out is going to give you better performance, and if you can do it with multiple instances, do it with multiple instances on the same box, because it's you know, you're trying to find where that pain point is. You know, you can maximise the performance so far in a particular element, but you hit some other kind of issue, and sometimes it's locking. I mean, you know, 5.4, which we announced this week, obviously removes some of the locks on InnoDB, but you still get the same locking situation on my ISAM. You still get the same locking situation on InnoDB. It hasn't gone away. We've reduced it, but we haven't got rid of it. And it may well be that just by spreading it out, you might find that although you're locking for the same amount of time, you're locking for the same amount of time over 4 instances instead of 1, and so therefore you increase your throughput. Because while you're locking, your machine is almost idle. I mean, by comparison, what it would be doing if it was sat there reading and writing rows all the time. I don't know whether that necessarily answers your question, but that's what I have found doing these kind of tests. You know, you hit a bottleneck. It doesn't have to be physical. It can purely be within the system or even within the application. And anything that you can do to spread that out is a good thing. And if you find that you're not hitting it, you're not getting the best performance out of your single machine, then multiple instances may be the way to go.
Would, if you were replicating the same database upon many instances on many, many boxes,
Yeah.
would it be better to have one slave instance and then chain the others that are
Yes.
local to that? Okay.
Yeah, and that's something I went over in my tutorial. And if you get that problem, because that stops the network,
Yes.
the network contention issue. Yeah, and that's actually a very good example. And something else that I've done in the past is actually replicate to a slave as a second instance, and the slave is then responsible for replicating out. And so you get really, really fast replication from the master to the slave on the one box, and then you replicate out to the other slaves. Is there anything else? Yes?
Just thinking, the multiple instances, maybe another thing to help on the IO. From what I gather this week, the incorporate technology is
Yeah.
just MySQL, except the way it's read. So if I have the multiple instances and I just use the capability edition of incorporate,
Yeah.
that can make a possible difference. Because now the way it is working with 350 is much faster than the normal way.
Yeah, yes. So, sorry, it's a very quick answer to that very long question. Yes. We should probably talk afterwards. Again. Yes.
It's kind of different, my question, but you can say EC2 yet, because we have the 8.4 extra large instance.
Yeah.
A single instance of MySQL does it, and then you get worse performance than one instance.
Yeah. And that's probably a function of MySQL rather than a function of the box that you're working in. And that's something where 5.4 will probably help, because it will just improve the way in which you can we use the resources of the machine. But yes, and I mean EC2. I mean, I want to stress EC2 is great because it's a very good way of seeing actually how Amazon do it. Amazon have EC2, they use Zen, they deploy your instance, but they're actually running on comparatively small number of machines for your individual item. You can see how they get maximum performance that way. Okay, anything else? Okay, thank you very much, everybody.